Hi, so in this video I want to talk about some techniques for breaking out of nested loops. Sometimes when we have nested loops we need to break out of the outermost loop while the code is running in the innermost loop. Now unfortunately Python doesn't provide a language mechanism for doing this. Other languages like Rust, for example, do have that, but Python doesn't. So let's look at an example and see what I mean by this. So let's do a very simple example. Let's say that we have a matrix like that, which is basically just an array of arrays, right? So in Python, you could represent it this way. You could use a list of lists. And our goal here is to find, iterating through the matrix from top to bottom and left to right. So basically as we go through 0, 0, 1, 2, 0, 1, 3, 4, and so on, we want to find the value and the position of the first negative number. So in this case, the answer we're looking for would be the value -2 located at row index 2, 0, 1, 2, right? At the index 2 row, and then the column index would be 0, 1, 2, 3. So it would be at 2, 3. Now to find this element, we could use a nested loop, but when we find the element in the inner loop, we need to break out of both loops, both the loop that's iterating over the rows and the loop that's iterating over the columns. Unfortunately, break only breaks out of the current loop of the code block that it's running in. So let's take a look at an example. We might try this. So let's start with basically this, and I'm going to need the index, so I'm also going to get the row index as well as the row, and I'm going to use the enumerate function. That's going to return the index and then the element of m. Now, what are the elements of M? Well, they're going to be lists themselves, right? They're going to be the rows of the matrix. So we'll do that, and then we'll do the same thing. We're going to say for column index, comma value. Now we're just iterating through the values of the row. So in, and again, we're going to enumerate the row this time. And we're just going to check. We're going to say if the value is less than 0, then we want to print something. So we'll print, let's say, found negative element, and then we'll interpolate the value at position, and then we'll interpolate the values inside kind of like coordinates. It's going to be the row index and the column index. Okay. So we're going to do that, and then we're going to break. But of course, the problem is that it's only going to break out of this, so it's not going to continue looking on this row, but it's still going to look now at the next row because the outer loop is still going to continue running. So as you can see, we can see that the first time it hit the negative number, it found the -2, but then it continued running. It ran now for the next row. So it found -1, as it was iterating now over that row, and then it did the break again. So it didn't give us the -4, but it still gave us this, which isn't what we wanted. We only wanted to stop at the first result. We just want the first result. So as you can see, we need to break out of both loops. So that's what I mean by breaking out of the nested loops. So we could try this approach, which is to use a flag basically to track if our outer loop needs to break or not. So we're going to say break out equals false. We'll start with a flag that will be equal to false. I'm going to take this code, paste it, and then we're going to fix it here. So what we're going to check is we're going to say, well, if we have to break out of this outermost loop, then break. And then in here, when we do find the element, that first negative element, we're going to want to break out of the column loop, right? Of the one that's iterating the columns in the row. We're going to want to, before we break, set our flag to true. And so now what's going to happen is that this value is going to be true. It's going to break. It's going to continue running the outer loop. That flag now is going to be true, and now it's going to break out of the outer loop. So if we run this, we get exactly what we want, which is just the first element. So while this certainly works, it's really not very elegant code. We have that flag that we have to keep track of, And then someone reading this code is going to have to think a bit to understand what we're doing. That's what I call inelegant. I don't like that approach. So is there a better approach? Well, yeah, maybe. I mean, here's one that we might be able to use. Do you remember the else clause that for loops have? Well, if you're like most people, you probably don't use it, or maybe you've never learned it, or you learned it and you forgot it. So let's go over what that clause does. It's actually quite useful for a case like this. So let's say that we're going to iterate from 0 to 5, and we'll just print the numbers. And then we'll say if I is greater than 3, we're going to break. And then I'm going to add an else clause, not to this if here, but to the else. So I unindent, and I make that part of the for loop. And then I'm going to say print else clause executed, like so. So if I run this, you'll notice that it prints the numbers 1, 2, 3, 4, and then it did a break, so it didn't print 5, and this didn't execute. Now on the other hand, if I don't have the break in there, let's copy paste this code, and let me make this full screen. So I'm going to take out the break statement here. So it prints out the numbers 0 through 5, and now you see that the else clause executed. So what does this mean? Well, this means that the else clause executes if the for loop completes. So first of all, the else is only going to get executed once the for loop has completed, but it also needs to have completed without a break statement. So this is why you don't get it in this case here. Here we did break out of the loop, so the loop completed, but it completed early. It had the break. It encountered the break statement. So the else isn't going to take effect. The else block isn't going to get executed. So what I do, because I find this confusing and other people reading this might find it confusing, I basically always add a comment to the else line to say else, and then I'll put no break. So then in other words, for the loop, and then otherwise, if there was no break, then print the else clause executed or whatever code you want. So now we can use that to our advantage in the previous example. Let me go ahead and grab the previous example. We'll grab this one. And let's paste it. So now what do I want to do? Well, I want to break, right? I still want to break from here. But what I'm going to do, I'm going to put an else statement on the inner for loop. So else, remember, this means no break. So if there was no break, that means that we want to continue the outermost loop. So we're going to use the continue keyword. So that's just going to basically say, yeah, continue iterating this outer for loop over here. Now, if we reach this line over here, because let's say that we didn't have a break, right? So we iterated through all the values. We didn't have a break. We hit continue. We now go over here, right? We now continue the next thing. If there was a break, that means that we're not going to execute continue yet, right? So at this point, we're still continuing the block of this loop over here. So what we can do here, therefore, is break. Because the only way we're going to reach this line is if the break was encountered here. Otherwise, we would just continue. And so you can repeat this if you think for multiple levels as well. You just have to keep doing else continue break, else continue break. You just keep repeating that. But if we run this, we get the same result. So this works as well, but although it may be more Pythonic than our first approach, it's confusing code. I really don't like it much either. I still prefer it to option number 1 because it's, I think, more Pythonic because we're using this continue and break and the else clause. But I don't like this code either. I think for someone, looking at this code, when they first look at it, they're going to be scratching their head as well, thinking, what's going on? So is there a better way? Yes, there is. There is another thing that we could use, and you remember something called exceptions? Very often people think of exceptions as errors, but it's not. Exceptions are used for error handling, but they're used for other things as well. For example, when a for loop iterates over an iterator, how does it know when to stop iterating, when it's finished iterating? Well, the iterator, because remember what the for loop does with an iterator, it basically just calls next, 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 next until it's reached the end of the iterator. How does it know that? Well, the iterator will raise a stop iteration exception to indicate to the for loop mechanism that, hey, I don't have anything left. And then the for loop just ends. Now, when you write your for loop, you don't see an exception. You just see that the for loop completes. So exceptions are also used for flow control, essentially. That's not just for error handling. So we could use the same mechanism to indicate to the outer loop that the inner loop is done, has found what it needs, and then the outer loop needs to stop iterating. So we could use a custom exception. You might be tempted to do that, and that would be, I guess, okay. That wouldn't be my choice. So we could create a new class called foundElement, and we're going to inherit from exception. So this is going to be an exception, and this class really doesn't do anything other than provide a name to this exception. And then what we're going to do is we're going to take our original code again. So let's take this one. Let's paste it over here. Now, what are we going to do? Well, here, instead of breaking, we're going to raise an exception. We're going to raise the foundElement exception. So, of course, what we need to do now is we need to catch that exception, and we're going to catch it in our outermost loop. So let's indent that. And we're going to catch basically the foundElement. So except foundElement. And if that's the case, we're going to break out of our outer loop, right? So now we're basically using a raise that's going to trickle up, and it's going to eventually reach over here, right, in the code block over here. And then we're going to handle the exception, and we're going to break. And of course, this is also going to work quite well for multiple levels of nested for loops. You would just raise from the innermost, and you would just catch inside the outermost for loop. You wouldn't have to worry about catching it in all the intermediate for loops if you had more than just two like we have here. You would basically let the exception bubble up the stack, the call stack, up to the outermost loop. So if we run this, we again get the same result. But of course, I think, why create this needless custom exception? There's really no reason to do that. We can just use one of the built-in exceptions. And in fact, I would use the stop iteration exception. Just like so. And that's exactly what we want to do. We want to stop the iteration, so that's a good name for it too. So I would just use that. It works exactly the same way. It's just that we're using now one of the built-in exceptions. So I think that's a little bit better. So far, this is actually the solution that I like the best. It's very Pythonic, and it scales really well. As you expand the number of nested for loops, then it doesn't really overcomplicate the code. You still have just a single raise and a single try, no matter the number of nested levels that you have. But I don't particularly love it either, and I don't love any of these solutions. When I see coding patterns like the one above, what I'm looking at is what are we actually trying to achieve with this code? Well, we're trying to find the value and the position of the first negative value in our matrix. And to me, this screams of we're trying to return the value and the position. So to me, this sounds like, well, this should be a function that just returns when it finds the negative value. And then we don't have to worry about exiting iterations, exiting for loops at all. And if you were actually including that in a larger chunk of code, you'd also be simplifying your larger chunk of code, because instead of having something like this in the middle, you would really now just have a single function call, and you could name the function in such a way that it's very descriptive. That's the way you should name your functions, right? It's going to be a very descriptive name, and it's going to be easier then to read that larger chunk of code, because you're not going to have to stop and try and figure out, okay, what is this doing in the middle of this larger chunk? So we're going to write a function. And we can call it find first negative element. Okay, yeah, it's a long name, but you can use completion afterwards. It doesn't matter. It's quite descriptive. Find the first negative element of this matrix. Okay, and so we're going to basically do the same iteration. So we're going to code over here, and actually, yeah, I guess let me take this code. So of course now we're going to iterate over matrix, and then we're going to iterate over the elements of the row, so over the columns in that row. And then we're going to say if value is less than 0, we're just going to return. We're going to return the row index, we're going to return the column index, and then we're going to return the value. That's it. And then of course, if we don't return, right, so if we've now finished both things, in order to keep the returned value of this function consistent, I'm going to return none for all of those. So I could say none, none, none like so, or if you want, you could also write none, comma, and then just multiply that by 3, like so. And then in our larger code, well, we would just say row index, comma, column index, and let's spell it out to keep it consistent with what I had before, column index, comma, value equals, and then find first negative element, and we'll pass it m. And then here I can just check to say if row index is not none. Now I have to use is not none. You cannot say if row index, because the row index could be 0, which means that this would be falsy, and then we wouldn't do this print statement that we had before, right? Basically, I'm going to take this over here and just print. So if you were just to say if row index, then if the row index happened to be 0, you would skip this print, and that's not what we want. So you specifically in this case have to test for none, because that's the only time, right? If it didn't find the value, this is when row index would be none, and that would be the only time that row index would be none. So then we execute this code and we get the same thing. So now you can imagine if this is in the middle of other code, you know, you got larger code chunk over here, and you know, you've got lines of code, then this is very easy to read, as opposed to having this kind of code interleaved into it. And that to me is the best solution. Not only does it avoid all the complexity of breaking out of multiple levels of nested loops, but it also simplifies the code. It makes it more readable, it's more concise, and it's also easier to unit test. And that's something that's also should be a concern when you're writing code in a production environment. You should be thinking about writing code that's easily testable as well. Now, I'm sure there are other clever ways of doing this that I just haven't thought of here. These are kind of the ones that I think are probably the most common. But I doubt that their simplicity will be as good as the function approach that we just did. Remember too that you will need to look for a technique that is going to allow you to break out of multiple nested loops, right? Multiple levels of nested loops, not just the 2 that we used here in our example. And then the function approach will work therefore equally well for these other cases as well as the one that uses the stop iteration, right? That raises the exception and lets that trickle back up, bubble back up to the outermost loop. And that's it. Short video on how to break out of nested loops. Thanks for watching.